Hello, everybody, and welcome to the webinar today. We still have a few people joining, so we're going to wait a few minutes, let everybody join, and then be back to get things going. Thank you.
Thank you, Bo. So we are still waiting for the participants.
Yeah, I think we're going to get things going. Hi, Jay. Okay, everybody. Thank you and welcome to today's webinar. What is continuous verification? My name's Bo Roberts. I run marketing at OpsumX, and I'll be the host for the webinar today. Just a couple of announcements and some little housekeeping before we get going. If you have any questions that you'd like to ask our presenter, you can submit those questions using the GoToWebinar control panel. There's a section there for submitting questions, so please submit your questions. Don't wait until the Q&A to do that. If you have a question, just submit it, and then that gives us time to prepare for the questions at the end. And let's see, there's also there's a couple handouts that you can also find in the GoToWebinar control panel that are a couple handouts that are relevant for today's talk. You can download those. And yeah, we'll do the presentation today will be about 40 minutes, and then we will do a Q&A at the end. So let's see, without further ado, let's get started. Okay, for those of you who might not be familiar with OpsumX, just a little quick intro about us. OpsumX was founded in 2016. OpsumX is a venture-backed startup based in Sunnyvale, California, with about 70 employees worldwide. We have offices in the US and India. We have two products, Open Enterprise Spinnaker, which is a enterprise-ready distribution for Spinnaker, and Autopilot, which we're actually going to be talking about today, which is a continuous verification product. OpsumX also provides services for Spinnaker onboarding, training, support, strategy, anything to do with Spinnaker, basically. So with that, we'll get going. One quick thing that we want to do at the beginning, we like to start off our webinars with a couple poll questions. This gives our speaker, our presenter, some insight as to who's in the audience, and he can tailor the presentation a little bit based on that. So I'm going to put up a couple questions, and if you could just answer those, and I'll also show you the results so we can see who's in the audience. First question, are you currently doing continuous delivery? And if you are, with what percentage of your production applications? So if you wouldn't mind just quickly clicking on your answer on the poll, we'll, okay, we've got people. Okay. I'm going to give it a few more seconds, and then if everybody could just vote, that would be great. Okay. A few more seconds, and then I'm going to close this poll. And there we go. So we're going to close that. And in terms of the in terms of the results, looks like we've got a fair amount of people who are doing continuous delivery. So that's good. All right, and the second question we'd like to ask is, let me see there. Okay, second question we'd like to ask is your organization currently evaluating or using Spinnaker? If you could answer that question, that would help us know who's in the audience, and it'll allow Jay, our speaker, to tailor the presentation a little bit. Let's see. Okay, we still have people voting or answering. I'm going to wrap it up in about 5 to 10 more seconds. So if you'd like to answer the question, please do so now. And looks like everybody's done it. So I'm going to close the poll, and there we go. Looks like we've got some people who are using Spinnaker and a fair number who are not using Spinnaker. So that's good information. Okay, so with that, I'm going to turn it over to our speaker today, who is Jay, who's a principal engineer here at OpsumX. And Jay, I'm going to turn it over to you now.
Thank you,
Hello,
Bo.
Jay. Yeah, there you go. Okay.
Thank you, Bo, for that introduction, and a warm welcome to all the participants over here taking time off to attend this webinar. So thank you for taking the poll question. I see a good mix of audience, mostly who are aware of the CI/CD world. So we are all here to learn about what is continuous verification, or CV. So what is this buzzword is all about, right? Organizations around the world are looking to increase the velocity of the software delivery. It's a no-brainer, right? So the quicker you make your feature or software available to the customer, you get the earlier feedback, and that sets you ahead of your competition. But in the process of doing this, speeding up your delivery, can you afford to compromise on your quality? Obviously, no, right? So, is it a good idea to introduce a manual intervention just to ensure that the things are in order, ensuring quality is in place? Yeah, that would be an option, but that is counterproductive because we are trying to increase the velocity of our release. So, this continuous verification is all about striking a balance of improving or speeding up your delivery process without compromising on your quality, in the process eliminating any manual intervention. So we're all here to achieve the organizational efficiency. Moving on to slide. So I'm sure most of you have some experience of software, if not in development in some way or other. But for the people who are familiar with the software development here, would appreciate when a feature is given to you for review, code review request, right? How efficient you would be when it is like tens of lines of code change. And when you're given a large feature which involves thousands of lines of change, how complex would it be to do justice to your evaluation? This is the same problem what the software industry was been facing traditionally in the software development process. So typically, survey shows that in the traditional development software process, you take about 18 months to make a major release of your software. That means the product manager or the product owner have to keep their fingers crossed. What if they miss the release window? They have to wait months together to make their feature available to the customer, right? And the other problem with this months of software development is the feature heaviness, right? So once you push a bulk of changes together, the time to find the bugs out of it and root causing the problem increases proportional to the amount of time you took to delivery. So like this is a no-brainer to say like the earlier you catch the bug is the quicker your process is. Moving on to the slide. So this is what we've been talking about, right? So as a majority of the crowd over here are aware of a CI/CD platform. On the left-hand side is where the software developer writes the code, and it goes through this continuous integration process of a build and test. Once the software achieves its maturity, it is put into an artifactory and then handed over to our ops team. The ops team could employ a combination of a manual and automated verification process, but the majority of the time, the validation of whether the software is good or bad is manual. Once the stamp of approval is given by the ops team, then it goes on to the delivery and finally reaches the customer. But there is a clear gap between the CI part and the CD part. That's what we are trying to address using this continuous verification. Moving on to the next slide. So the same analogy of like introducing a bulk versus incremental changes applies to this continuous delivery. The whole idea here is like don't build up your process, keep on delivering incremental changes. When you reduce the size of your changes, the complexity decreases dramatically, and the chances of finding any bugs increases manifold. Obviously, the cost of identifying a bug early and fixing it is like no time. This significantly improves your mean response time, right? So imagine the case of days together to find a bug and fix it in your traditional software development versus within an hour you can find the issue and fix it. Yeah. So this is what I've been talking about, right? The verification is error prone, especially when it is a manual, right? We have different manual gates which are strictly guarded. And why is software organizations struggling? Why not have an end-to-end automated flow? How can is there a time when we can completely eliminate the manual process so that the moment the developer checks in the code, it goes through all the process and it's delivered to the customer? That would be a true world of a CI/CD platform with continuous verification in place. Yeah, moving on. So just look at the scale on your left hand side. When your scale of operation is relatively small, the parameter to judge how good your software is also relatively small. Then the manual verification makes sense. But as your complexity of your software increases and the more features you add it to the application, the number of parameters needed to judge how good the software also increases. And when this scale increases, your manual verification cannot scale up. Traditionally, like you will be held back in your loop of a continuous trying to do this traditional process of testing phase, validation phase, and then handing over phase. This is where CV will be very handy. And how do we go about it? We'll see in the next slide. In the previous slides, we saw there is a clear gap between your the dev process as well as your deployment process. The continuous verification is trying to fill in this gap, right? It has to be a platform. The platform should be able to risk assess your software. Like if there is a risk with the software, it should be able to tell where is the risk. And if it is good to go, it should make a decision of uh, promoting it to production. At the same time, it has to ensure that your release is good in terms of compliance and policies, what it is traditionally required of. And if at all, if you find a issue and if it is a no-go, we also go ahead, the continuous verification platform should also go ahead and validate and give the findings in a way why it is not good. Not only finding out the issues, but also given weightage which can be actionable and which can help you in diagnose the problem. So this should be the ultimate goal of a continuous verification. So how is this whole funda of intelligent verification built into place? So when you come to the world of artificial intelligence with the machine learning, this cycle of observe a system, right, and learn the behavior of the system and apply the learning in your decision process. And this cycle has to repeat again and again. The more number of cycles it goes through, the decision taken by the system tend to be more accurate. In this process, a typical software verification would make use of a statistical analysis. What does that mean? It is not about it today. The system builds the knowledge about the software over a period of time. And whenever a new release comes in, with this past learning, it could able to clearly identify and articulate is there a risk associated with this software? Is there something abnormal observed here? Right? And when a software is running, it also exhibit the different matrices. So with our ML based algorithm, we should able to clearly say like what is the normal behavior and what should be the abnormal behavior, which the user should be concerned about. And we strongly believe a true deep understanding or analysis of software can be seen only from the logs generated out of the system, because like those are actually written by the software, embedded into the software and emerged during different phases of its life cycle. So we employed natural language processing to interpret the logs generated by the application. So all these forms the ecosystem to make this continuous verification a solid platform. So what would be the typical requirement or the characteristics of a continuous verification platform should be? To be a widely accepted system, it has to interoperate with the most of our major data sources out there, like be it the Prometheus or App Dynamics or like Sumo Logics of the world, we should be able to interoperate with that. So that is where the scale can come into place. It's not only that the application could be written in different technologies and use different tools. We should be able to understand all these tools and interpret them correctly to make a valid judgment. Any software should be simple to use. When I say simple to use, people do not want to go through a complex learning curve just because it brings in some value. The moment it is simple to use, people won't mind integrating into the system. But that is not the ultimate requirement, right? People dislike disruptions, right? If your production system should be as undisturbed or less disruptive as possible without compromising on any of your software development process, safety process. So for an ideal verification platform, I would say these are the key criteria to exhibit. So what is that OpsumX have to answer this problem of continuous verification? We have this platform called Autopilot. This picture we have already seen where there is a gap between your CI and the CD process. Autopilot nicely fills into this place where in your if you have a staging environment or if you are comparing your current release against a past release or like learning from the past, whatever could be the use case, we provide a seamless risk assessment of how good your new release is or if it is bad, how bad it is, right? At the same time, we ensure that all the policies and compliance requirements are taken care, and we give a neatly presented report at the end of our analysis if we say that the software is not good to be moved to production, why it is so, like what are the major areas you should concern about, what is the topmost priority things and what are the least impacting ones. So that's where the autopilot is built on to give you this seamless experience. Moving on. So let's revisit this site where we started, like what should be the ideal characteristics of a continuous verification platform should be. We talked about increasing business velocity. So ideally, If you have a build and if it is a production ready at any point in time, that's what we call it as on demand, right? So we should not be working towards a release, like going through multiple stages and the stressful moments before making the release. At any point in time, you should have a confidence on the build. What you have currently on hand is ready to deploy to the customer. And with the continuous verification platform, you have the confidence of reduced failure. When we say reduce failure, the software is not going to reduce, but it reduces the chances of rolling out a software which can be buggy. So that's where it reduces the risk of exposing like unmature software into your production environment. So with all this in hand, your operational efficiency is achieved. So any small investment in this continuous verification platform in the early stage of a CI/CD platform is going to benefit you in the long way. Moving on to the next slide. So let us look at some of the features of the autopilot feature. So as I was telling, if you are looking at only one characteristics or one parameter for application, that is not a good judgment of completely analyzing your software. In this case, we have taken care in autopilot. We look at all the characteristics of our application. For example, we look at the logs, that is called the deep inspection of the actual behavior of your running system. In addition to that, we look at the various performance metrics exhibited by your application, be it be the latency time or network throughput or your disk utilization, right? In addition to this, the platform on which your software runs also plays a major role. So we collect metrics out of your virtual environment or the Docker container environment and look at your JVM characteristics or other behaviors. So we make a collective decision about looking at all these parameters and give you a consolidated risk score. So what do we mean by consolidated risk score is like the analysis what given by the platform should be actionable, right? When it is given in a risk score, which is like easy to interpret and easy in your decision making and automating your release process. In addition, if you want to look at like in a segmented wise, what is the risk you found with the logs, what is the risk you found with the metrics or APM, that also is made available to you. So if the concerned person is on move, right, and he want to be alerted of anything unwanted happens, then you can configure the system to alert, right? For example, like when the particular API is behaving abnormally, right? The response time increases beyond a threshold. Set me an alert. These kind of alerts can be pre-configured, and you get it notified on your device. Get confidence with the risk score. Okay, the obvious question would be how would we believe, like how good you are telling me a score, how do I believe about it, right? The system or this platform is defined in such a way, it is a learning system, right? We look at your application and the corresponding services and give an indication of how good or bad it is. Then we give an option to the user to feed the system. If we feel that this can be ignored or this is how it has to be treated, the system learns from there and move on. So this is a complete platform which gives you a seamless assessment of your application. Moving on to the next slide. Yeah, I would love to have a live demo of our product, but unfortunately some limitations prevented us from doing this. So instead I went ahead and shared some live reports of what we had. So here is a snapshot of our analysis which happened. So on the top right corner, if you see like there is a score box which says like is the metrics and the logs are considered for this risk analysis. So in this particular analysis, the metrics is not included, so it is not applicable. And from the logs part of it, we found something critical, right? And we told like this release is bad, it's a no-go, right? On the log clustering side, if you look at it like this analysis consisted of around like 100K lines of logs, and such a huge log is analyzed in a seamless way and presented in what is most impacting, right? If you look at the number of events, it is 85. So like 100K lines is reduced to 85 events. That's what you need to look at it. This drastically reduces your diagnostics time and brings focus to what is most important to you. And within these events, we have a different categories of what are these critical out of it, and how many of them are errors, which can be you can make a decision to live with it or to make a decision of no go, and how many of them are warnings here. So this is how a live system of analysis would be presented to you. In addition, we have if you are making use of like a ELK kind of stack, you can readily view what are the logs used in this analysis. So like it is fully integrated system. This is a one place where you can look at all the parameters what you would be interested in knowing. You need not look at each and individual data sources to find out what is happening. And that's the it's a central place for your risk assessment. Yeah. So here is another screenshot where this is a live example of how we use it. The platform what we are talking about is used in our own software development. So we have set up a CI/CD pipeline in Spinnaker where each and every commit from our customers goes through this risk assessment. So here we captured one screenshot of there where there was a null pointer exception, which was skipped through our regular unit testing under the validation process. But using autopilot in the continuous verification platform is able to clearly catch this and then categorize this as critical error, because a null pointer exception is something is a no-go. But as you can see on the top right side, like this categorized critical error. But as a user, you think that this null pointer exception is introduced by a third-party application, which is not going to impact your regular business flow. You can choose to ignore it. So you can reassign or reclassify this particular error to say like, hey, don't worry about it. If you do that, then the system learns from this input. And the next time, whenever the system sees such an exception on the similar stack trace, then it would not flag it, because you already fed the system that it should not be treated as a critical error. And other thing, what you can see, even multi-line traces like this is like neatly presented to you. Then even in environment where if your application is running on a Kubernetes or in a Docker Compose, Docker Swarm, you need not look at multiple sources of logs and try to analyze. This is a single place where we aggregate the logs, give you a consolidated risk assessment. And as on the top, you can see different categories of this assessment. So unexpected is what the application thinks that it shouldn't have happened in this new release, but we caught it. Please check. That's how it is categorized and presented to you. Here is a screenshot from our APM risk assessment. So there's a different color codes talk about what is the normal behavior, like how a system. So this historical behavior is learned over multiple runs of your software. And whenever a new release comes up, it is like benchmarked against the normal behavior. And if at all we see a significant difference or some abnormality, the user should be concerned about. Based on the difference or jump in the quantum, the corresponding score is being assigned to this so that the user can act on it and take corrective action. Here is a screenshot. People familiar with the Spinnaker will appreciate that Spinnaker has this option of introducing any custom stage. So if your software delivery process involves Canary analysis, then you can plug in autopilot in the automatic Canary analysis stage, where you can bring up a baseline and your new release can be brought up in a Canary mode and then do a comparison. And if it is good, the decision to promote it to production would be made. And if it is not good, based on the analysis from autopilot, you can revert or abort the deployment. So I think with this, I open up to give it back to Bo.
Yeah, thanks, Jay. Um, let's see. Did you want to just point out the resources here?
Yeah. Thank you for reminding that. So, these are all the public resources accessible to you. You can come and listen to our blogs. Not only about autopilot, we have this OES platform, and this is an active blog. You can keep looking at frequently, so that it's not only like a marketing place, but it's like a lot of learning can happen there, and we can be reached through Slack support and through email support as well.
Okay, thanks, Jay. I think we're gonna move to the Q&A now. If you have a question for Jay that you'd like to ask Jay, please type it into the questions section in the GoToWebinar control panel, and we will take as many questions as we can. Before we head into the Q&A, there's one other poll question that I'd like to put up, and let me bring that up here. Yeah, so a lot of times we get asked for people who want the presentation slides sent to them. We don't post them, but we are happy to send them to you after the webinar. And the easiest way we've found to just do that is we put up a poll question, which I'm going to do right now. And in this poll question, you can kind of specify any of these things if you want us to follow up with you. So as I mentioned, if you'd like to get the presentation slides, please check that. And a couple other things, if you'd like us to follow up with you about Spinnaker training, onboarding, or support, if you need help with deploying Spinnaker or scaling it within your organization, please get in touch with us, or we can get in touch with you. We also have something called a continuous delivery strategy workshop, which is a complimentary kind of 2-hour online session. And if you'd like to potentially take advantage of that, you can check that in the poll question as well, and we'll follow up with you about that. So yeah, it looks like everybody, or almost everybody, has voted. So I'm going to close the poll in a few more seconds. And additionally, you can always follow up with us at hello@OpsMX, and we are doing a lot more webinars these days now that everybody is working from home. So please go to opsmx.com and check out our webinar calendar for upcoming webinars. So now at this point, I'm going to turn it over to Jay for the Q. Take a look at the questions that we have. Let's see here. Okay. Okay, Jay, the first question is, how does Autopilot identify errors in my application? Do I have control over the decision criteria?
Yeah, that's a very good question. So that's a complex problem to solve, right? So what we have done is we made use of an extensive analysis and research to find out what would be the most commonly occurred enterprise software errors would look like. And we took a dip about all the major technologies and tools used and identified the different categories of error. So that is the learning which the software starts, and so that is only the self-learning part, right? But as and when we present the report to the user can keep feeding in, right? He can reclassify already identified error from one criteria or one criticality to other, or if the software missed something to flag it, then you can go and say, hey, look, this has to be treated as an error going forward. So that way you constantly teach the system so that it's learning over a period of time, so that your confidence about the software in making an informed risk score increases dramatically.
Okay, great. Second question that we've got here is, what are the data sources that are supported?
Yeah, usual question we get wherever we meet the customers and when we talk about continuous verification. See, that is an obvious question because this is like we are trying to work and the CI/CD platform or DevOps platform is evolving, right? The number of tools and the technologies which pop up every day is mind-boggling. But what we have done is like we looked at the most popular tools and technologies used. For example, if you look at the logs, ELK or the Elastic has become the de facto standard for most of the logs, right? So we support ELK, and we also support Sumo Logic, and Stackdriver, and we are soon going to support Splunk as well as in our log sources. And when you come out to the metrics part of it, like we support the Prometheus, right, and Neuralink for your APM, and App Dynamics is in there in our pipeline. So Datadog, we already have a integrated support. So these are all some of the major tools we have, and yeah, we are working on other popular tools as well, so that we can climb integration with any tool available in the market.
Okay, great. Let's see, we've got one more. Yeah, just want to reiterate, if you have a question for Jay that you'd like him to answer, please enter it now. And we have one other question. Let's see. This question is, I have custom scripts for CI/CD. Can Autopilot integrate them?
Yeah, that's a great question. So, when we developed this platform, we kept in mind because there is no standard rule, no one size fit all when it comes to the DevOps world. So we have developed this software in a way where it is readily pluggable into your custom script as well, right? If you have like API based REST app compatible applications, and if we can issue REST queries and get responses, then we can straight away plug into your environment and start using it.
Okay. Let's see. Think that might be the end of our questions. Again, if anybody has another question, please submit it and we'll take it. Otherwise, we'll probably look to wrap things up soon. Let's see if any other questions come in. Okay, while we're waiting for that, let's see. I had a couple of people send me a message saying that they, for some reason, maybe I closed the poll too fast for getting the presentation slides sent to them. I can't put the poll up again. At least I don't know how to. But if you would like the slides and you weren't able to get answer the poll question, please contact us at hello@opsumx.com, and we're happy to send you the slides. Not a problem. Okay. Looks like we don't have any other questions, so I think we'll probably look to wrap things up now. Jay, any final comments or?
Yeah, I hope your time is well spent today in this COVID time where every one of us are locked in our home. So thank you for attending.
Yeah. All right. Thank you, Jay. That was a nice presentation. Very interesting. Thank you, everybody, for joining us today. As Jay said, we hope you're all staying healthy and safe out there, and we hope to see you on our next webinar. Go to opsumx.com to check out our webinar calendar, and we'll see you again soon. Thank you, everybody.
Thank you.